Hello, my name is Andy Hammermeister, and I'm the director of the Organic Agriculture Centre of Canada at Dalhousie University. It is my pleasure to be offering this short presentation on the future of organic horticulture. I've titled this presentation, A Canary in the Coal Mine. So when we look at organic agriculture, I really love to come back to this presentation or this petal diagram that's provided by Sofert and Ramankutty in 2017. And in this petal diagram, you can see many different indicators of performance of different farming systems. And the red circle that you see represents a conventional standard for comparison. If the petal exceeds the red circle, that means that organic is outperforming conventional. And if the petal has a really light shade or is really faded, then there's a higher level of uncertainty on the data. So we're not as confident in the data set. So with this data set, it's really clear that there's a lot of different indicators that we can use to evaluate organic agriculture. And really, I like presenting this because I think that we should be looking at agriculture as multifunctional, and especially organic as having multifunctional benefits. But ultimately, the success of organic agriculture is going to depend upon how well organic agriculture performs in relation to farmers' needs and expectations. And so it has to be profitable and resilient, and there needs to be other benefits that are attracting farmers to it. Otherwise, organic farming would not be happening. Associated with that often is the yield, or the production per unit area. And yield is a key driver of interest for organic farmers. It's very important. It affects profitability. But it also is one of the key issues that many in the global community are talking about in terms of world food supply. However, it's also consumers that are responsible for driving forward organic agriculture by creating the market that adds a premium value. And consumers are looking for many different characteristics of organic, which may include lower pesticide residues, which organic is very successful at achieving, but also improving higher nutrient density and health benefits. And so this is where organic perhaps could be more intentional and more focused. So one of our challenges here is dealing with resilience and yield stability, especially in the face of climate change. And while we've seen that organic agriculture can have very many positive impacts on environment, as we see all of the green petals here, we need to recognize that ask ourselves, is organic intended to be the key driver of ecological performance and in terms of improving performance, or should environmental benefits be the drivers of successful organic farming systems? So let's take a look at climate change, and I've thrown in this little graphic, this cartoon that I've modified slightly. I've put on the birdcage horticulture instead of what was there, which was Australia. And we recently have been going through a series of national consultations on organic research priorities in Canada. And in those consultations, it became very clear that climate change is having a much greater impact on organic production systems as of late. We're seeing pest pressure increasing in horticultural systems. They're coming earlier, staying longer. There's more cycles of pests, and some new pests are entering into Canada. Now, normally Canada has had the natural advantage of having winter for helping with pest control. However, we're seeing that advantage gradually disappearing. We're also seeing increasing disease pressure, and some of the biological controls for insect pests are starting to lose their efficacy, perhaps, as the timing of biological controls evolution isn't matching the cycles of the pests. Some producers are also reporting that oils and sulfur, which are used to help control some of the disease issues and so on, need to be applied at temperatures at a 12-hour temperature less than 25 degrees Celsius. So we need 12 hours of less than 25 degrees Celsius in order to not burn the crop. And in British Columbia and Ontario, we're starting to see periods of weeks where we're not reaching that temperature below 25 degrees. So some of the producers are starting to recognize that some of their tools are not available to them anymore. And this is resulting in higher pest pressure because effective controls aren't being applied. In addition, we have issues with frost and drought occurring with climate change. So is organic the canary in the coal mine? So this is how I started thinking of it, is conventional agriculture is masking many of these impacts of increasing pest pressure by supplementing with or addressing those pressures with chemical controls. And so perhaps without those controls, organic is a bit of a canary in the coal mine, representing an early indicator of the stressors that are coming into our agricultural systems. But then I got thinking that is organic really intended to be a canary? Shouldn't it be a model of adaptation and resilience in farming systems? And instead of organic being the canary in the coal mine, perhaps it should be the salvation of agriculture. So how would we go about doing that? Well, we need to go back to our principle of ecology that's outlined as one of the 4 key principles of organic agriculture. And we need to be taking this principle of ecology and applying a culture of innovation and continued improvement towards best practices. So how can we move forward ecologically? And the term ecological intensification has been thrown around a lot in recent years. And it can be defined as being characterized by having high internal regulation processes, moderate resource inputs, low nutrient losses, and high productivity. We can achieve ecological resilience and adaptation through a number of practices, including improving our genetics, improving resilience in the crop by biological treatments, ensuring that we have really good soil health, one of the foundations of organic, enhancing biodiversity, either genetically, having multiple crops, intercrops, rotations, or even introducing biocontrols, biorepellents, and sanitation, and so on. However, is ecological intensification really sufficient for addressing the needs within organic agriculture? We're seeing more and more demand and use of organic pest control products and pesticides. And so I'm not sure that this is a desirable direction to go. As farms become bigger and they become less diversified, they become more vulnerable to a lot of these pests and other stressors. So this is where I think that we can complement or supplement ecological practices through technological innovation. There's many new smart technologies that are becoming available that we should be applying in organic agriculture much more quickly, because really the more we understand about the plants and the ecosystem that we're working within and the soils, the more quickly we can adapt and manage problems before they become too large. So aside from using remote sensing technologies to identify different pest pressure within individual fields, there's also opportunities to apply smart technologies to identify individual pests or individual plants and be very precise in applying amendments. So these could be pesticides. Organic pesticides are notably expensive. And so if we can target the pesticide applications to be much more plant specific, then we could reduce costs and environmental impact or unforeseen consequences if necessary. We could also be applying treatments to plants much more specifically and precisely, whether it's nutrients, foliar applications, or perhaps even biological treatments. I think we also have some opportunities in smart technologies to look at robotic systems, and certainly robotic weeders have been talked about a lot, but I'm focusing here on robotic harvesting systems, not so much for saving labor, which is also really valuable, but I think that we need to be optimizing the timing of picking of fruits and vegetables so that we're getting the fruits and vegetables in their optimum condition so that they have better storage life, both in the grocery stores and at home. And we also want to ensure that we're optimizing the quality characteristics and meeting those nutrient density and flavor components that farmers or that consumers are expecting. We're seeing tremendous advancements in technologies that are sensing our environment and being able to monitor it. There's so many different sensors out there for the soil, the climate, and what's going on the plant. When all of this is being applied together, you can have whole orchard management solutions, for example, where you have pest monitoring that's going on in an automated way, and perhaps even pheromone disruption technologies that are being applied, along with climate monitoring and so on. So as we apply all of these different systems together, we can see that that we could have a much more comprehensive plan for managing problems in the organic fields. There's some new technology which I find really fascinating, such as this sensor that's being attached to a smartphone with an app, and it's basically detecting the volatile organic compounds being released, in this case, by blight in tomatoes. So the leaf is emitting these volatile compounds, and it's being detected by the analyzer and being handled by a cell phone. So you could have an early detection and warning system that could allow earlier treatment and management of diseases. So ultimately, I hope that our goal would not be to allow organic to be the canary in the coal mine. Rather, we should ensure that it is not a canary. We should be building multifunctionality in organic farming systems, and we need to be moving towards greater resiliency and yield stability as a key. Ecological intensification is really important, but it may not be sufficient to achieve all of our needs as we deal with more and more climate and consumer stressors. So I believe that smart technologies are going to become more and more important for organic agriculture. Perhaps to enhance the ecological components of our systems. But we must remember that these technologies need to be scale appropriate so that they're accessible by all farmers. So I hope that prompted some discussion, and I look forward to having opportunities to chat with you all again sometime soon. Thank you very much.